All right, guys, so this is chapter 3, part 2. So these are going to be mostly your calculator questions. Um, so you definitely want to get that out for them. Remember on the exam, part of your exam is going to be no calculator, and then the other half will be calculator questions. So make sure you definitely bring that on the day of the exam. Okay, so the first one says, what's the interest rate required for an $8,100 investment to double in 20 years if the account is compounded daily? Okay, so this is what we're talking about. We're talking about your amount. So your starting amount, 1 plus the rate over the number of times that it's compounded raised to the number of times that it's compounded over however many years. Okay, so that's a formula that I'm going to give you. You need to be expected to know how to use it. Okay, so what are we trying to find, right? It says what interest rate is required. So that means that what I'm going to try and find is R, right? So what other information do I know? $8,100 investment, so that's going to be P. R is what I'm going to try and solve for. And then I want it to double in 20 years. So if I double 8,100, that's going to give me 16,200. And I want to do that in 20 years if it's compounded daily, right? So if something is compounded daily, that's 365 times. So 365, and I want to do that in 20 years. All right. Okay, so we're going to try and solve for R. So if I divide the 8,100 over, it's going to give me 2. So that's 1 plus R over 365. Now 365 times 20 . 7,300. All right, so I need to get rid of that on both sides. So how could I do that? All right, so I can take the natural log on both sides. So that's natural log of 2 equals the natural log of 1 plus R over 365 to the 7,300, which is then natural log of 2, 7,300 ln 1 plus R over 365. All right, so my next step is going to then divide the 7,300 over. So that's ln of 2 divided by 7,300 equals natural log 1 plus R over 365. All right, now, in order for me to get rid of the natural log on the right side, I need to raise both sides with E. So it's E to the natural log of 2 over 7,300 equals 1 plus R over 365. You're going to subtract the 1. And then you're going to multiply by 365. So 365 times E to the natural log of 2 over 7,300 minus 1. All right, so that's when I plug in my calculator there. So 365 parentheses E to the, we do that in parentheses, so ln of 2 divided by 7,300 minus 1. Okay, so I get R is 0.0346, which comes out to be a 3.46% interest rate. Okay, next one. John wants to invest $1,300 into a savings account that has a 4% interest rate compounded continuously. How long will it take for John to have a balance of $4,500? Okay, so this is the other equation. You're compounded continuously, right? And again, I'm going to give that to you on the test. All right, so we want to reach 4,500, so that's going to go on this side. And then we're starting with 1,300, and we're trying to figure out how long will it take. So that tells me I'm trying to solve for t. Right, and we have a 4% interest, so 0.04 t. Okay, and I'm just going to solve for t now. So I got 4,500 over 1,300 equals e to the 0.04 t, which is then 45 over 13 equals e to the 0.04 t. You're going to take the natural log on both sides. And then divide by 0.04. All right, so if I plug that into my calculator, I've got the natural log of 45 divided by 13 divided by 0.04. So that is 31.043 years. Okay, 57. Radioactive substance reproduces itself at a rate that the population of the substance quadruples every 3 hours. At t equals 0, there are 6 grams of the substance. Write an equation for the number of grams of the substance at t hours. Okay. All right, so if it says it quadruples every 3 hours, right, that means that my rate here is going to be 4. Okay, so R of t, so you have your initial amount, which we said was 6, times the rate, which if it's quadrupling, that's so 4, and then every 3 hours, right? So you're thinking t is going to represent 1 hour, right? So if it's every 3 hours, after 1 hour, you're only 1/3 of the way done, okay? So that tells me that my exponent should be t over 3. Okay. Now, if it was said 3 times per hour, you're going to do 3t. So again, you just have to figure out how long is one cycle, and then that should help you write your exponent. How many grams are present after 48 hours? So t in this case is 48. So R of 48 is 6 times 4 to the 48 over 3. And that I'm going to plug in. So 6 times 4 to the 48 over 3. All right, so that's 2.576 times 10 to to the 10. It's pretty big. That's a lot. All right, now it says how many hours will it take for the substance to reach 1 million grams? Okay. So we're trying to figure out when does R of T equal 1 million. All right, so that's 6 times 4 to the T over 3 equals 1 million. All right, so that's 4 to the T over 3 equals 1 million divided by 6. Now I got the natural log of 4 to the T over 3 equals natural log of 1 million over 6, which is then T over 3 times natural log of 4. I'm going to divide by the natural log of 4. And then multiply by 3. Okay, so I'm going to plug that in my calculator now. Sorry if you guys didn't see that. I forgot my calculator was up. Okay, so we're going to do 3 natural log of 1 million divided by 6 divided by the natural log of 4. And then hit enter. So I get 26.019 hours. Okay. And then the last one for chapter 3 is your logistic function. So this is going to be one where you're probably going to need to plug it into your calculator. All right. So it says fruit flies are placed in a milk bottle with banana and yeast. And suppose that the fruit fly population after T days is given by P of T. Okay. Determine the initial population of the fruit flies. Okay. Remember this number here at the top, that's your carrying capacity for this. All right, so it's not, the population is not going to go above that. All right, so that should help you when you type it in. So you're going to go to your calculator now. You're going to go to y equals, get rid of anything that's there, and then type in the equation. So 230 divided by 1 plus 56 e to the negative 0.37x. All right. Now remember, a logistic function looks kind of like that. All right. So that's kind of what we're hoping for when I graph this. Now when I go to the window, all right, I'm going to change it to be, I'm going to start 0.30 seems okay, and then I'll adjust it if I need to, and then the y values should go to about 230. All right, and then I'm going to hit graph. Okay, so that looks pretty good to me. I got the logistic function pretty much all there, so I'm set. I'm pretty much set to go now. So now determine the initial population for the fruit flies. So that is when time is 0. That's when you're starting. Okay. So P of 0 now. So remember, you can just type in, because your function's already plugged in, you hit trace and then just hit 0 because that's the value that you want. And you hit enter, and this is your answer here. So 4.035. So 4.035, or roughly 4 fruit flies. Okay, part B says, what is the population after 5 days? So this one we are doing P of 5. All right, so you're going to do the same thing again. So trace 5 now. And your answer is 23.456. Which is roughly 23 fruit flies. Letter C, how long will it take for the population of fruit flies to reach 180? All right, so you're doing P of T now equals 180, okay? So you're going to try and look for the intersection of the graph and when it hits 180. So go back to y equals, and you're going to type in 180. I wonder if I can make that bigger. Okay, hit graph now. All right, so you're going to try and find that intersection. So you're going to go second, trace. You're going to go to number 5, and then you're going to hit enter. You want this blinking X here to be close to the intersection. So hit enter 3 times. 1, 2, 3. So that would be your answer right here, 14.341. And then the last question says, how many fruit flies are present when the population is growing the fastest? How many days will it take for this to occur? Okay. So remember, when it's growing at its fastest rate, that's half the carrying capacity. All right, so the population is continuing to grow at a rapid rate, and then once it hits half the maximum carrying capacity, then it starts to slow down. So the moment that it hits exactly half is when it's going the fastest. Okay, so half of 230, right, which is what we started with, is going to be 115. Okay, so we're trying to figure out when does my population reach 115. So I'm going to go back to y equals, plug in 115, and then graph. So we're going to do trace. And my answer, 10.879 days. All right, guys, so that's chapter 3.